All right, hi guys, welcome to your Unit 12 review. I'm going to pull out the notes from the last lesson that we did just to show you these again. So I put stars next to the ones that I think you should memorize. I know that this is a lot. I'm going to pick 2 of those to go on the test. And so I picked 2 of them to go on the study guide, so you know which 2 it's not going to be. So that really narrows it down for you. But you do just kind of have to know those. You can always work them out, but then it's going to take a really long time, and you're better off just doing this. That's my like pep talk for them. So here's the 2 that I picked for here. The first one is cosine. So it's write out the first 4 non-zero terms and the general form, or the general term. So cosine is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and then it would be plus x to the 8th over 8 factorial, and so on and so forth. And so your general term, it is alternating. So we'll have -1 to the n, and then x to the 2n, because we want all the even ones, over 2n factorial. And you don't have to say where it starts necessarily, but I just always like to. This is going to start at 0. Like this is the 0th term, the 1st term, 2nd term, 3rd term, and so on and so forth. All right, so for arctangent, it is x minus x cubed over 3. This one also alternates, plus x to the 5th over 5 minus x to the 7th over 7, and then it'd be plus x to the 9th over 9, and so on and so forth. And so your general term, again, this one alternates, and it's x to the 2n plus 1, and then over 2n plus 1. And again, it's going to start at 0. So this is the 0th term, 1st term, 2nd term, 3rd term, so on and so forth. All right, so number 2. And we're going to use these 2 to answer like the rest of these. That's why I had you write those out on there, because we're going to use them to answer the rest of the questions on the front of this page. So what is the coefficient for x to the 4th in the Taylor series for cosine of 2x? So you would take 2x and plug it in everywhere that you see an x, and we only have to do it for the one that's going to be to the 4th. So we're looking at this term right here. So if we plug 2x into that, that's going to give us 16x to the 4th over 24. And I just asked for what's the coefficient. So that would be the 16 24ths, and that's going to reduce to 2/3. So we're just looking for the coefficient that goes with the x to the 4th. And number 3 is the same thing. What is the coefficient for x to the 15th for arctangent of x cubed? So if we want the power to be to the 15th, we're going to take this x cubed and plug it into this term right here. Again, you don't need to do all of them. You just need to pick out the one that you're looking for. So it'd be x cubed to the 5th over 5, and that would be x to the 15th over 5. And again, I'm just looking for the coefficient, and so it would just be 1/5. All right, number 4, write out the first 4 non-zero terms for x times cosine of x. So again, we're looking right here, and we're just going to multiply each of the terms by an x, basically just distributing an x through it. It's x times all of this. So that'll be x minus x cubed over 2 factorial plus x to the 5th over 4 factorial minus x to the 7th over 6 factorial. So that's all that is. You're just basically distributing an x into that. All right, what are the first 4 non-zero terms for arctangent? So again, I'm using these 2 that we wrote out up there, so you can just look back at them. Arctangent of -x and then over x. So everywhere you see an x, you're going to plug in a -x, and then we're going to divide the whole thing by x. All right, so for this first term, if you plug in a -x, it'll just make it -x. If you divide by x, that'll give you -1. Let me zoom out a little bit so we can see both at the same time. All right, so here, if you plug in a -x, you're going to have -x cubed. The negatives will cancel. This will be positive. And then if you divide by an x, you'll just have x squared. So here, if we plug in a -x, that's going to make this negative. And then if we divide by an x, it'll just be x to the 4th. Basically, it's just changing the sign, and then you're dropping a power because you're dividing by an x. This is going to be plus x to the 6th over 7. All right, and then I think I'm done using all of this. I'm going to scoot this up. The Maclaurin series for a function f is given by all of this. What is the value of the third derivative at 0? So we want, oh, this froze, hold on a second. All right, there we go. All right, so we want the third derivative at 0, and that would go over 3 factorial and then x to the third. So it's Maclaurin, so we're centered around 0 here. So we want to look at what the third, or the term with the third power would be. So we're going to have to plug in 3 for n. Again, you could list them all out, I suppose, if you want, like plug in 1, plug in 2, plug in 3, like it's starting at n is 1 here, but we only want the power of the third. So you're just basically picking out the one that you want. So this would equal x to the third and then over 15. So 1/15 x to the third. And we're just going to solve it for this part. This is what we're looking for. So we don't need this really. We're just setting the coefficients equal. 3 factorial would be 6. So we're going to multiply a 6 to the other side. So it'll be 6/15, and then that's going to reduce to 2/5. All right, here we are taking a derivative, and these look like really messy, but you're really not doing all that much. That -1 to the n is just going to kind of stay there. And this is just the power rule. This 5n minus 1 comes down, and then you drop a degree. So this will be 5n minus 2, and then over 5n minus 1 factorial. And then just to simplify that, one of the 5n minus 1s is going to cancel. And so this will be over 5n minus 2 factorials. This is your final answer. So I just canceled one of those out. All right, let f be a function given by, so we're given this function f, and then g is your integral of that function. Find the first 5 non-zero terms in the general term for g around 0. All right, so I always write this out. I guess you can if you want to. I just suggest that you do, because it's about staying organized. How far do I need to go? The first 5. Actually, I think I wrote out 6. But I'm going to need to go all the way to that because this first one's going to end up being 0, and it says write out the first 5 non-zero terms. The reason I know this is going to be 0 is if you do g of 0, if you plug in 0 here, it's your integral from 0 to 0, which is going to be nothing. So 1, 2, 3, 4, 5. So that's our first 5 non-zero terms. Now we're going to need all these derivatives. So I'm just going to go ahead and find these off to the side here. So g prime, and you do a derivative of an integral, they're going to cancel and you just get what's inside. So that's this function here. So 1/2 e to the power, what is it, -2x. So second derivative, it's going to be that, and then chain on a -2. So the 2's will cancel, it'll just be negative e to the -2x. Third derivative, and again, it's just going to be itself, and then you chain on a -2. So negatives cancel, this will be 2 e to the -2x. Fourth derivative will be -4 e to the -2x. And then fifth derivative will be 8 e to the -2x. So I'm just writing those all out off to the side so that I have them. And then we're going to go ahead and do each of these terms. So g prime of 0. So if you plug in 0, anything to the 0 power is 1 times 1/2. So it's 1/2 over 1 factorial x to the first. I'm actually just going to leave everything. I'm not going to simplify it down because when you go to write the general term, I think this said write the general term. In the general term, it's easier if it's not simplified because it's easier to find the pattern. All right, so second derivative at 0. Again, anything to the 0 power is 1, so it's just going to be -1 over 2 factorial x to the second. Third derivative at 0, that's going to be 2. Fourth derivative at 0 will be -4. And then fifth derivative at 0 will be 8. All right, and then we need to write out the general term. I'm going to run out of room here, so I'm going to just come down to the next line. So first of all, it's alternating. So we want, and you always have to decide whether you want to start at 0 or start at 1. I'm going to start at 1. I'm going to have this be for n starting at 1, because then I can call this the first term, second term, third term, and this is all going to be over just n factorial, so that'll be a little bit easier. And then it'll be, x to the n, x to the first, x to the second, x to the third. So let's see, we want the, I messed up something. Oh, no, I didn't. That's negative, positive, negative, positive. Okay, I stuck it in the numerator, not out front. You know what, let me fix that because that's going to bother me. It doesn't really matter, but I just want to be able to see it better. All right, so we're going positive, negative, positive, negative. So I want the even terms to be negative. So this will be -1 to the n plus 1. If we wanted the odd terms to be negative, it would just be n. But like, for example, if you plug in 1, like for your first term, 1 plus 1 is 2, this would end up being positive. So you can always check it. All right, and then we want n factorial in the denominator. That takes care of that part. And now, and I also have x to the n here. That takes care of the variable. So we need to figure out this pattern, and it's geometric. So we have 1/2, 1, 2, 4, 8. We're multiplying by 2 each time. So it's starting at 1/2. We're multiplying this on here. And then we're multiplying by 2 each time. And it's going to have to be n minus 1. Because I'm starting at 1 instead of 0. And again, you can always check, like if you plug in 1, like for this first term here, 1 minus 1 would be 0. Anything to the 0 power is 1. It's just going to give you 1/2. For your second term, if you plug in 2, 2 minus 1 would be 1. 2 to the first would be 2 times 1/2 gives you 1. Like you can check it. If you plug in 3, you're going to end up with 2. If you plug in 4, you're going to end up with 4. So that is your general term. Finding the general term can be hard because you have to find that pattern there and then write it out. Also, that just looks really scary because there's a lot in there. But again, this just makes it alternate. This takes care of the x to the whatever, and then we have n factorial in the denominator. All right, number 9, a Maclaurin series is given by this. Find the interval of convergence. All right, so this always starts with a ratio test. And I'm going to leave off this -1 to the n plus 1 because we're doing an absolute value, so I don't need that part. It's just always going to be positive. All right, so I set that up, and then I'm going to do the reciprocal. And then we're going to see what we can cancel out. So we'll just have a 3x in the numerator, and actually that's all that we can do. And then we're going to evaluate the limit as n goes to infinity. This is n to the first, and this is n to the first, so we just use the coefficient, which would be 3x over 1, so it's just 3x, and that needs to be smaller than 1, just by definition, that's your ratio test. And then we're going to divide over the 3. So we get that our radius of convergence is 1/3, but to get the interval of convergence, you have to test the endpoints. So we're centered at 0, it said it was Maclaurin, and we can get a distance of 1/3 away from 0. So we're going to have to test -1/3 and +1/3. So I'm going to plug in -1/3 for x in this original series here. So if I plug in -1/3 times 3, that'll be -1 then over n. So this is kind of interesting how this happens here. This is going to make all the odd terms negative. This is going to make all the even terms negative. So if all the odd terms and all the even terms are negative, the whole thing is just negative. So it's a negative series for 1 over n. And that's the harmonic series, so that diverges. I'll just go ahead and write harmonic series. Or you could say because it's a p series where p equals 1. And then we're going to test +1/3 So we're going to plug positive a third in for x up here. Now that would just be 1 to the n, which is just going to be 1. So actually, I'm just going to leave that out, and this would be over n. So that's alternating. We're going to do an alternating series test. And you can probably see already that it's going to work. I'm just going to write this out to be thorough. And so our interval of convergence is that we are going to leave out the negative 1/3, but include the positive 1/3. All right, and then this is the last one, just kind of 3 parts to it. So our function is ln of x plus 1, and then we're given the Maclaurin series for ln of x. It's right here. So use the series to write the first 4 non-zero terms and the general term for this function. So they gave us ln of x. We just need to plug in x plus 1 everywhere we see an x. All that's going to happen is the plus 1s and the minus 1s are all going to cancel. So we're just going to have x minus x squared over 2 plus x cubed over 3 minus x cubed over 4. Like basically just the plus 1s and the minus 1s cancel. And then we want the general term. So first of all, it's alternating. So we're going to have negative 1 to the n plus 1. We want all the even terms to be negative. And then we have x to the nth over n. And n is starting at 1 for this. So that's the first term, second term, third term. I just like to write that so I know whether I started at 1 or 0. All right, letter B. The radius of convergence is 1. That means we don't have to do a ratio test. We're told that it's 1. Determine the interval of convergence. Now it's Maclaurin, so we're centered at 0. And the radius is 1. So you can get 1 unit away from 0. So we're going to have to test negative 1 and positive 1. The thing that's kind of not fair about questions like this is if you didn't get this general term, then you wouldn't, like you'd be stuck here because this is what we're using when we evaluate this, because it says for function f, and this is function f right here. So this is the one that we're using. So we're going to plug in negative 1 for x. So that'll be negative 1 to the n, and this is going to turn out exactly like the one that we just did on the other side. This makes all the even terms and the odd terms negative, so the entire thing, well, that was a really bad sigma. Oh well, I'm going to go with it. Makes the whole thing negative, and then this diverges because it's the harmonic series. And actually, I think the positive one turns out the exact same as on the other side too. So if you plug in positive 1, this part's just going to be 1. And yeah, it is. It's going to be an alternating series. I'm just going to write converges by alternating series test. It's the exact same as it was on the other side of the paper. So our interval of convergence, we are going to leave out the negative 1, but include the positive 1. And then letter C, write out the first 4 non-zero terms of the Maclaurin series for f prime of t cubed. And then they bring up this g of x thing. So let's just do this part first. So first we're going to find f prime of x, and then we're going to plug in t cubed. So remember, this is f of x. We're going to do the derivative of that. So this will be 1 minus, now if you bring the 2 down, the 2's are going to cancel, so that'll just be x. And actually that's what's going to happen for all of these. So plus x squared minus x cubed. So that's our derivative. And then we're going to plug in t cubed. So t cubed squared would be t to the 6th, and then t cubed cubed would be t to the 9th. All right, so that takes care of this first part. Write out the first 4 non-zero terms of that. So g of x is the integral of that. So to get g of x, we're going to do the antiderivative of what we have right here. So that'll be x minus 1/4 x to the 4th plus 1/7 x to the 7th. And actually, I think it just said the first 3. You could keep going if you want, but it just said the first 3 non-zero terms for that one to approximate g of 2. So we're just going to plug in 2, and you don't have to simplify this one down. So that would be that approximation.